video, we are going to see definition of Laplace transform, formulas and properties. So first let us look into the definition of Laplace transform. So here this is the definition. The Laplace transform of a function f of t for all real numbers t greater than or equal to 0 is the function f of s, which is defined by f of s is equal to L of f of t, which is equal to integral 0 to infinity e to the power minus st f of t dt. The definition is integral 0 to infinity e to the power minus st f of t dt is the definition, where here s is called the parameter which is be real or complex. And the notation what we are using here for Laplace transform is f of s or L of f of t. Similarly, we can also denote inverse Laplace transform. So from this usual notation, if we take L inverse on both sides, we can have L inverse of f of s is equal to f of t. So this is the notation we are using for inverse Laplace transform. So next let us move on to formulas and properties. So these are the list of formulas we have to remember while doing the problem. So first formula is L of 1, which is equal to 1 by s. So we are obtaining these set of formulas by just substituting the function in the definition of Laplace transform. For example, if we take the first formula L of 1 equal to 1 by s, in the definition of Laplace transform, that is integral 0 to infinity e power minus st f of t dt, that f of t should be substituted here as 1. If we substitute it as 1 and if we integrate it, we'll be getting the answer as 1 by s. Similarly, if we follow the same procedure for all these functions, we can obtain these list of formulas. That is, second one is L of e to the power minus at is equal to 1 by s plus a. Similarly, in case of L of e power plus at, the answer should be 1 by s minus a. And L of t power n is equal to n factorial by s to the power n plus 1. So similarly, we can see all the remaining formulas here. So these are the list of formulas we are going to use to solve the problems under Laplace transform. And here these are the list of properties. First is the linearity property, where a and b are constant here. If it is like this, we can take a and b outside the notation L of f of t. So similarly, second is called the per shifting property. Here we are having defined this property for e to the power at. Similarly, we can also define it for e to the power minus at. If it is e to the power minus at, here the answer should be L of s minus a. So now here third property is L of f of at is equal to 1 by a into f of s by a. And similarly, fourth is the multiplication of t property, and fifth is division of t property, and sixth is the derivative of the function f of t, and seventh is the integration of the function f of t. Actually, if you notice here, this what is this f of s minus a, what is the meaning of f of s minus a? Meaning of f of s minus a is, we are finding f of s is actually, the usual notation is L of f of s is equal to L of f of t. L of f of t. So from this, if we want to know how to write L f of s minus a, here it is L of f of t, L of f of t, where s should be written as s minus a. This is the meaning of f of s minus a. That is, we have to find out L of f of t. In that result, we have to substitute s is equal to s minus a. Similarly, this f of s by a is nothing but L of f of t we want to find out, in which s should be substituted as s by a. So likewise here, this f of s, here we are having f of s. So this can be written as minus 1 to the power n dn by ds power n into, here directly f of s can be written as L of f of t. So here no need to replace anything, because here f of s is directly it's given. So this here f of s is equal to L of f of t. So here we have written like this. And similarly, this is also in the same way. We can have like this, s to infinity f of u is nothing but L of f of t. That is, instead of f of s, here we have denoted as f of u because limit contains s. So here instead of f of s, we are using a dummy variable u and we are writing it as L of f of u, which is nothing but L of f of t into du. And similarly here, and similarly in the seventh property also, here it is L of f of t divided by s. So these are all the list of properties which we are going to use to solve the problems under Laplace transform. So we have to remember both the formula as well as the properties. So now inverse Laplace transform. Similarly, what we had for Laplace transform, here for inverse Laplace transform also we are having the same list of formulas as well as properties. If we are thorough with the formulas and properties under Laplace transform, then it will be easy to remember the formulas under inverse Laplace transform. That is, here for example, there under Laplace transform we saw L of 1 is equal to 1 by S. So here if we take L inverse on both sides, then here it becomes 1 and then here it becomes L inverse of 1 by S. So this is what here we have written, right? So similarly the same thing happens here in case of for shifting property, that is L of e to the power minus at, we know that it is equal to f of s minus a. So if we taking inverse Laplace transform on both sides, left side becomes e to the power minus at, here it becomes L inverse of f of s minus a. So here, so finally we can have the formulas L inverse of f of s minus a is equal to e to the power minus at, which is the second formula. So similarly we can have the set of formulas for inverse Laplace transform and similarly the properties also. Okay, so in the next video, let us see how to solve problems using Laplace transform using these formula and properties.